Hello, my name is Andrew Penner, and I'm the president of the AEE Canada East chapter. We'll introduce the topic for today. It's focusing on indoor air quality and efficiency and the relationship between those two things. I think historically, ventilation has been a bit of a challenge for energy engineers. Fresh air comes at a cost, so always looking for ways to improve the efficiency of our ventilation systems. And we're really happy to have Ted Vergis come to us virtually from Texas today to talk to us about some solutions and strategies. So he's been with Inverid for over 8 years now, but before that he spent more than 10 years doing other energy efficiency stuff, energy storage, renewables, etc. So he's been in the industry for a long time. And we're really happy to have him here. So Ted, why don't you can take the reins of presenting, and I'll go on mute and let the show be yours.
Well, thanks so much, Andrew. Very grateful for AEE carving out the time for us today. I'm going to go ahead and share my screen here. Perfect. Looks like that came up. We're also grateful for our partnership with Odell and Associates, who represents us in Ontario. We've spent quite a bit of time in market in Ottawa, Toronto, and other areas. On the line today with me as well is Karthik Radhakrishnan, who's our application engineer, who designed a lot of these slides and on a regular basis performs indoor air quality procedure calculations. Today, you're going to be learning about Inverid. Inverid is an air filtration company. What we do is we specialize in the indoor air quality procedure. So you're going to learn how and be thinking about how to apply filtration, gaseous filtration, to reduce your outside air requirement by 60 to 80%. I am a AEE member myself. I went through the Certified Energy Procurement Professional course in Washington, D.C., and we had a lot of really great kind of best practice sharing there during the class with various facility managers from universities and mechanical engineers. And one thing that you mentioned, Andrew, is that outside air is expensive to condition. It's expensive from a first cost and ongoing perspective. So if we can safely reduce the amount of outside air per building standards, then we end up with, number one, great indoor air quality, and number two, a great way to reduce our overall energy consumption. Just a quick plug for Inverid here. We are the ASHRAE Product of the Year for 2019. We also got first place in the green building category. And ASHRAE said that Inverid safely removes all molecular contaminants. And we have the ability to remove things like CO2, which is incredibly unique to our product, as well as the big ones like formaldehyde. And we'll touch on formaldehyde today, which is present in the built environment in all applications, pretty much, offices, schools, warehouses, etc. And the full range of VOCs, volatile organic compounds, from indoor air, sufficiently to reduce outside air safely. Jumping into our content today, we've white labeled this to make sure that it complies with professional development hours, but quick agenda. We're just going to talk about kind of what's driving this, decarbonization and things of the sort. We're going to talk about the indoor air quality procedure and where that exists in code and how to apply the indoor air quality procedure. We'll also take a look at some local case studies, as well as some case studies from brand names that you might be familiar with, to take a look at the impact and analyses that have been done by the U.S. Department of Energy, the Massachusetts Department of Energy Resource Program, etc. So let's talk about external market drivers. Let's jump right in since we have limited time and I want to leave plenty of time for questions. Obviously, wildfire season last year was pretty brutal. And in terms of that season, outside air was no longer fresh air in many situations, right? So what we saw on many of our installations is that actually the indoor air quality was better than outside air quality. Now, this might only happen occasionally. There's other market factors driving what ASHRAE and others are doing with respect to outside air. One of those big topics is decarbonization and net zero. Getting credit for reducing outside air significantly is a big consideration. You also take a look at financial uncertainty during the pandemic. For example, we saw pricing of HVAC equipment and other equipment increase drastically. How can we protect ourselves from future price increases by shrinking the size of required equipment on these buildings? And then further, when we talk about reducing outside air, we don't want to have to compromise on indoor air quality. And indeed, the indoor air quality procedure allows us to do that. And so source control really becomes the key around indoor air quality and providing what we call building resiliency. So how do we make buildings more resilient? How many times have you walked into an existing building and you just know those outside air dampers are turned off? Well, if there's source control going on in that building, if you have a device or devices removing the volatile organic compounds that we've traditionally tried to dilute, well, then that building has increased resiliency for the future. Moving on here, introducing the solution. So the indoor air quality procedure. This might be new for many of you. You might have heard of the indoor air quality procedure before, but not used it. Or you might have tried to use it and gone, that's weird. It really requires a lot from the engineer of record. Well, within ASHRAE 62.1, since the pandemic, there's been massive amounts of research. Interesting keynote that I heard during an ASHRAE call the other day was that COVID is actually now the most researched airborne virus of all time, even more so than flu, for example, which has been around obviously far longer. And a lot of this research has driven us to really realize that dilution of contaminants is really efficient compared to filtration of contaminants. The technologies that we have advanced so much over the past, let's say 15 years that Inverid has been in business, that we are able to more effectively provide acceptable environments for human occupants that reduce or minimize adverse health effects by using these standards and by using new technologies or technologies that might be new to you. Indeed, also new standards such as ASHRAE 241, which is the control of infectious aerosols and essentially running buildings in pandemic mode, actually call out ASHRAE 62.1, the indoor air quality procedure, as a valid prerequisite. So all of these things are pretty phenomenal for reducing outside air and ensuring a healthy built environment. Moving on here, what this means is that historically we've looked at dilution to ensure good indoor air quality. So you look at the ventilation rate procedure and you see that the VRP and its prescriptive approach, if you want better indoor air quality, you need to increase the amount of ventilation that's going on. However, the market is quickly pivoting to a method of hybrid ventilation. And hybrid ventilation is using filtration, using source control and removal as that proxy for outside air. So you're essentially able to use source control to improve indoor air quality and reduce that amount of outside air required. This has indeed been adopted into Canada's National Building Code, Ontario's Building Code, as well as the IMC 403. So you can see here that the OBC kind of harmonized that building code effective of May of 2019, so relatively recently, calling out the indoor air quality procedure as a valid methodology of calculating your outside air. And indeed, the International Mechanical Code under Section 403 also allows for outside air reduction and calculations using the indoor air quality procedure. So what do we get from that? Well, we want to reduce energy. We want to improve things like humidity control, especially if it's cold, dry outside air. How can we improve the indoor built environment? We want enhanced indoor air quality. More and more tenants and owners are focused on this. We also want to reduce the impact of polluted outside air. And so one of the solutions here is to treat return air or air directly in the space. It doesn't have to be return air. It can also be air directly in the space with sorbent filtration. Sorbents are a specific type of filter that we'll get into that can remove gaseous contaminants without negatively impacting things like pressure drop across the system. What this enables us to do is reduce outside air requirements by 60 to 80% using the indoor air quality procedure. Moving on here, what are some of the benefits? Well, the benefits of the indoor air quality procedure and the air cleaning approach, there's many. But the new ASHRAE 62.1 Users Manual for 2019, which was recently published, basically says that the IAQp is a better methodology in several situations or may be more appropriate to use. And one of those situations is if the ventilation zone has unusual contaminant sources, then additional ventilation or air cleaning must be included in the design. And that additional ventilation or air cleaning required must be designed using the IAQp. This is very interesting, right? This is a massive pivot. When I first started 8 years ago at Inverid, the ventilation rate procedure was our default for ensuring acceptable indoor air quality. But now, if something weird happens, or if the space is weird, and there's unusual contaminant sources, then additional ventilation or air cleaning must be included, and additional ventilation or air cleaning must be designed using the indoor air quality procedure. So you're starting to see this publication of this pivot from your default being ventilation rate procedure to the indoor air quality procedure. There were also 4 scenarios stated within the 62.1 Users Manual where the IAQp may be more appropriate to use. So we already covered one, which is item number 4 there, which is when spaces may have unusual contaminant sources. But there's 3 other scenarios here, and I'd like you to kind of look at these and smile because there's a conclusion that we'll reach here after reading these. So one of the scenarios in which the IAQp may be more appropriate to use than ventilation is when a more cost-effective solution is desired. The other is when better indoor air quality is desired, or when outdoor air is not fresh. Let's say you're in an urban environment where the outside air louvers are next to a major roadway or next to an airport. I kind of look at these 4 items and say, well, geez, these apply to pretty much every building, right? Show number 1 to a developer, show number 2 to a tenant, and show number 3 to anybody out on the street during wildfire season or in a major metropolitan area. Item number 4 also is a little bit silly because ASHRAE has defined all K through 12 schools, all classrooms, as unusual contaminant sources. So remember, when you look at a classroom and table I1 of Appendix I defines all K through 12 schools as unusual contaminant sources, well, sheesh, that brings us back to the user's manual when it says, well, yes, there are unusual contaminant sources. So now additional ventilation or air cleaning must be included. And that ventilation or air cleaning must be designed using the IAQp. Why are classrooms unusual contaminant sources? Well, we've got space-related contaminants like stored arts and craft supplies. We also have occupants that have more bioeffluents. There's some odors there, and they also are more vocal. So we've got more, stuff off-gassing from children in that case as well. So let's talk a little bit about decarbonization. We like to look at this, and these are rough numbers here, but we like to look at this as the 40-40-40 rule, which is ventilation energy reduction is definitely the lowest hanging fruit in terms of where we can get energy back on these buildings. In terms of the United States, 40% of buildings energy can provide the total energy consumption of the US. And within that, 40% of building energy is due to HVAC, and 40% of that is due to HVAC energy within that building. So there's a huge opportunity here to show 6 to 10% reduction in the total building energy envelope by reducing outside air using the IAQp. In the case of using the IAQp correctly, I mentioned that we're essentially adding filtration. And many facilities folks will say, well, that means you're adding one more piece of equipment. That's going to increase cost to the design. That's not necessarily so. If you're adding a filtration, you can reduce your code required amount of outside air so significantly they can end up with smaller HVAC systems by providing that air cleaning. Additionally, the filter replacements for these applications are typically far less than the costs of the energy that we are saving. So this can actually relieve financial pressure. So you can add a piece of equipment to actually reduce total cost in the project, both in terms of OpEx as well as CapEx. In terms of what a 20,000 square foot building might look like, each time you deploy this solution, you might be shaving off 10 to 15 tons of peak cooling and several 100,000 BTUs of peak heating as well. And this enables us to downsize the chiller, eliminate or reduce energy recovery, and downsize required capacity of things like geothermal, where we've seen a lot of great case studies where geothermal well fields actually shrink in size. There's big first cost savings there. In terms of, I mentioned and kind of glossed over eliminating energy recovery requirements, you can reduce or eliminate energy recovery if you're bringing in less than 10% outside air. So with the case of the indoor air quality procedure, what you end up with is you actually end up with pressurization typically driving the minimum required outside air to ensure acceptable indoor air quality. And this is fully allowable with the IAQp and specifically in Canada as well. When you're looking at various climate zones, I mentioned the cost of filtration versus the cost of energy. You can see here that the IAQp designs, in terms of a cost per square foot to ventilate those buildings, significantly reduced with the IAQp because we're strictly bringing in less outside air. Jumping forward here, LEED and WELL also have points available for the indoor air quality procedure. So if you do have specific projects where you're looking to get points, you can earn up to 10 points under LEED and under WELL up to 7 total points for actually saving money on the project. So not only are we reducing first costs and operational costs, this is one of the most cost-effective way to get green building standard points as well. Where's the IAQp most frequently applied? It's most frequently applied in office buildings, K through 12 schools, colleges and universities, pretty much anywhere where you're typically looking at low exhaust. If you have specific applications like laboratories or places that have high exhaust, they're typically not going to be able to reduce outside air because remember, pressurization is really our moving forward a little bit. So let's talk about how codes and standards have changed. A lot of this is kind of new information. So nobody on this call is behind, and we're really having to shift how our mindset works. Look at how busy this slide is. This is everything that's kind of happened within ASHRAE 62.1 and ventilation within the past 3 years. Now 4 years, I guess. So let's hit some highlights here. So in February of 2022, Addendum AA to ASHRAE 62.1 2019 was brought in, which gave us defined clean air targets to hit, specifically with gaseous contaminants. All right. Addendum N to 62.1 2022, which came out in October of 2022, also gave us a levelized playing field, where Addendum N really states, how do I know a device is working sufficiently to reduce outside air? And one of the interesting things there is really using devices that don't produce byproducts. So it's great and all if you can take formaldehyde out of the indoor air in an office building, which might be off-gassed from particle board or from glue in the carpeting. But if you're just changing formaldehyde into something else like CO2 and water, well, that creates problems for the mass balance equation within the indoor air quality procedure. So using a defined testing standard that ASHRAE has released within Addendum N to 62.1 is really important. Now, also the mass balance equation, anytime we start going through mass balance equations, people start to nod off, but there is now an ASHRAE approved IAQp calculator from Addendum C that is out that Inverid uses when running these calculations. So we know we're doing these calculations correctly. Those are some of the highlights there. I also want to talk about the IAQp and how it's become so much more robust. So previously, when you looked at the ASHRAE 62.1 indoor air quality procedure, when you were looking at your ventilation rate number, 0.06 CFM per, all those types of things, and just using a table, there wasn't a whole lot of thinking involved. And then you went to the indoor air quality procedure, and a lot of the answers were, it's up to the engineer of record. Things like, what is an acceptable design compound and limit for things like formaldehyde? What's an acceptable limit of formaldehyde in an office building? Well, that's hard to know, right? And so what ASHRAE has done is taken a lot of these up to the MEP to define categories and said, no, we'll give them to you. So based on space type, ASHRAE 62.1 2019 Addendum AA gave us allowable limits of specific design compounds. They also gave us the emission rates of those contaminants. And further, they also gave us testing standards for defining air cleaning efficiency. Last is they gave us a calculator to make all this super easy and give us an easy button there. So just showing you here what the design compounds and limits are within ASHRAE 62.1 2019. The big one on this list is really things like formaldehyde. Formaldehyde has a very low design limit and a very high emission rate. So that's typically what drives the calculations. So if you see an IAQp calculator out there that's blowing up this design limit, it's probably not going to pass muster. Another interesting contaminant on here that I'll mention is ozone. Ozone's an outdoor generated contaminant, so it's not one of those contaminants that we can actually ventilate out of buildings. It's coming from the outside. So you want to select a product that definitely doesn't produce ozone, but you also want to select one that can remove ozone as well. Okay. Noticeably missing from this list is CO2. CO2 has traditionally, there have been limits in, for example, the lead pilot credit for IAQp, but CO2 is not a specific contaminant of concern where there is a called out design limit. Now, we can talk more about that, but there are ASHRAE position papers on what an acceptable limit of CO2 is within a space, and that's typically what organizations like ours plug into the IAQp calculator, is that specific design limit. Blazing through these here, I just wanted to show you all that the emission rates for each of these contaminants is provided, and the concentration in outdoor air based on major metropolitan areas is also in the calculator. So within our calculator for the IAQp, we have the concentration of things like formaldehyde, of ozone for specific cities like Toronto and like Ottawa. Air cleaning efficiency. This is where selecting a product becomes very important. This is why we're proud to be partnered with organizations like Odell, who have kind of vetted these things out with us and said, yep, this is a product worth representing. ASHRAE has given us specific methodologies for gas phase air cleaners to test these products and get everyone on a level playing field. One of these testing standards, how we test our devices, is ASHRAE standard 145.2. It's a single pass gaseous contaminant removal test, which ensures no byproducts. And we use our end of life efficiencies in the calculator to ensure that day one, the indoor air quality in these buildings is phenomenal. There are a few other tests here, but worth mentioning is under section E. They do call out that if a manufacturer believes that their device can't meet one of these other standards, that there can be custom tests allowed for each of these contaminants of concern, but the authority having jurisdiction, local code, must specifically approve that custom test in advance. So worth mentioning, it's probably worth just using a product that's already tested to something like ISO 10121-2 or standard 145.2. And off to the right there, you can see the third-party lab tested efficiencies for sorbent filters. Now, what is the IAQp really? And I don't want to belabor this too much because now we have an ASHRAE calculator, so we don't need to think about it too much. But realistically, what the IAQp does, different from the ventilation rate procedure, is it really hones in on ensuring acceptable indoor air quality and not just throwing a bunch of potentially contaminated outside air at the problem. And so what all of this does within the ASHRAE 62.1 is we have our indoor emission rates of each individual contaminant and design compounds. We apply an air cleaning efficiency based on the volume of air that's being treated by that device. And then we also get credit for that remaining outside air dilution, which is being done to maintain building pressurization. So that really kind of summarizes this calculation here for this mass balance equation. But to make it easy, you don't have to build your own calculator. Here's addendum C. The calculator already has preloaded each of the design limits for each of the design compounds based on space type. All you need to do, and Inverid's already done this for you, is plug in a device efficiency. And then it's the same inputs that you use for the ventilation rate procedure. What is your occupancy? What is your square footage? And what is the system efficiency? 0.8, 1.0. And this gives you your minimum outside air requirement, as well as how much air cleaning needs to be done with a device of that efficiency on each of the design contaminants. As I mentioned before, formaldehyde is typically what drives these IAQp calculations. Talking just real briefly about various technologies. So I've mentioned sorbent air cleaning. Our company did not invent this. We licensed these technologies from organizations like MIT and USC. They were originated during the space program. They're used on things like submarines and space shuttles. But what we did is commercialize it. And so basically we wanted to design a filter that is very low maintenance. So sorbent filters only need to be replaced once every 2 years. They're basically high surface area granules that are coated in a polymer. That polymer is what we license, and that polymer is very sticky to things like formaldehyde and can be sticky to things like CO2 as well, which is why it's used in submarines and space shuttles. These are both passive and subtractive. So typically you're going to couple this in a solution that has its own fan. That fan is going to overcome the static pressure drop across these filters themselves, and they're subtractive. What I mean by subtractive is that no byproducts are created during this process of capturing these contaminants. They do not need to be red bagged or red tagged during that once every 2-year maintenance cycle. So it's a very easy application to both apply and maintain. These air cleaning systems can be deployed in a variety of ways. So really all we're talking about is filtration here. We don't need to overcomplicate it. So you've got these filters here, you know the efficiencies on the contaminants of concern, you run the IAQp calculations with that new calculator, which we can provide after this call for anybody who needs it. And then all you do is you can select a fan filter box and treat air directly to and from the space. You can attach that to a ducted return system. You can place that into a sealing plenum. You can even drop this into RTUs or into open air mechanical rooms, which are plenums, and scrub that air sufficiently to reduce outside air requirements. Here's an example of what these filters would look like integrated into a curb. You can select a variety of sizes here, variety of number of filters, which would impact the amount of air cleaning done in that calculation. This unit here would have a fan off to the back, and basically you have the RTU up above this curb. HLR stands for HVAC load reduction. That's kind of an abbreviation for systems that are able to scrub contaminants of concern coming out of return air and reduce the amount of outside air that needs to be brought into that RTU. We get asked a lot because we talk a little bit about return air. Can this be integrated with DOAS applications? Absolutely. The IAQp can be designed with pretty much any system type. So you can apply it in a decoupled manner, serving large volumes of air, like, for example, a large auditorium, a church, a hotel conference center. You can also place this into mechanical rooms and help shrink the size of those DOASs up on the roof, because you now only need to bring in enough outside air essentially for building pressurization. We are also well paired with VRF applications. Jumping into a couple of quick case studies here, just a quick time check. We're about half an hour in, should be wrapped up within the next 10 minutes or so, so plenty of time for questions. Taking a look at one specific case study in Ontario. This is the large new library that's going in. Some of you might recognize this building. This is 3 floors of Class A library building, 172,000 square feet. 11 HLR modules were deployed there. Roughly 122 filters or so, individual filters within these boxes that have their own fans and power to those fans. This is also a LEED project. So 8 LEED points were applied here while reducing the total amount of outside air significantly to reduce that peak cooling load. Here's a quick little kind of snapshot of the total impact there. In terms of the outside air reduction, 12,000 CFM roughly were reduced by applying those 12 filter boxes. That's pretty significant. That's a 30% reduction in outside air. So a little bit less than what we typically see because LEED has a higher standard for indoor air quality than your standard ASHRAE building. But we were still able to shave off 86 tons of peak cooling capacity, more than making up for the first cost of these systems being deployed. Then we also just modeled out from that calculation there what the levels of the contaminants of concern in that space will be. If you look at formaldehyde, 33 micrograms per meter cubed is the limit. 33 parts per billion is the limit in terms of applications for ASHRAE buildings. We're half of that in this application here. Looking at another case study, Conestoga College, just outside of Toronto there in Kitchener. This is a project that was validated by the utility company. And so there were significant demand charge reductions and a one-time utility rebate of over $41,000. I'm not sure if that's US or Canadian, but pretty significant utility rebate there. I believe that's Canadian. The application here is this was originally designed to be a shopping center. And that shopping center was only designed to have 250 people in it. Well, normally you would have to significantly increase the amount of outside air to that space because the occupancy shot up to over 1,700 occupants. Instead, what they did was they deployed 6 of these modules, 72 filters into that space to cut that outside air requirement in half and not have to increase the system on that retrofit application. So this is real practical applications for existing buildings as well as new construction. If you'd like to read more about how the IAQp and sorbents can be deployed, I highly recommend you look into the US GSA study on sorbents, or look at the US Department of Energy study similarly, which models kind of the energy savings on a multitude of applications across many different climate zones. One I want to dive into here, just because from a climate perspective, it's relatively comparable to what we typically see in Canada. In the Ontario area is Harvard University. Harvard decided to deploy this application, and the Massachusetts Department of Energy Resources did a pretty significant third-party study on these applications. So you can see here, it wasn't just on one building, it was on a multitude of buildings. And we're going to hone in on Robinson Hall here, where the floor area is 45,000 square feet, 226 occupants, and the outside airflow was cut from 6,500 CFM down to 2,100 CFM, just using 2 filter boxes. The indoor air quality was monitored there, so we got to see the actual impact on a retrofit application of reducing outside air, but adding filtration, which led to a significant reduction of that outside air, 68%, and also significant reduction in terms of the contaminants of concern. So it's counterintuitive. By adding filtration, we actually improved indoor air quality. We think about that because dilution of contaminants is so far less efficient than extraction of contaminants. From an M&V perspective, from a cooling and heating standpoint, you can see the significant reduction in carbon emissions, ventilation costs, and ventilation energy as well. So slicing just with 2 filter boxes, slicing the CO2 tons of emissions from, just shy of 20 tons of CO2 per year down to around 6 tons of CO2 per year, super helpful for any decarbonization goals. So summarizing just real quickly here, we want to help you lower your capital expenditures on new projects. We want to help you reduce your operational expenditures. We want to increase building resiliency for new types of applications or retrofits on existing buildings, and expand kind of those occupancy profiles or space types that can be on existing buildings. And then if you have green building standards as well, we're here to help with that. Just another quick ad for Inverid here. We offer free design assist, obviously, with occupancy and square footage, as well as knowing the space type. Those are typically all the inputs we would need to figure out how much outside air can be reduced. We can also help navigating the LEED pilot credits, as well as getting well building standard points. And just getting a little bit more specific about various form factors. We make our own boxes to make this a drag and drop solution. So we have rooftop units that address VOCs, volatile organic compounds, and CO2. We have indoor units that address CO2 and VOCs. We also have units that just address the ASHRAE required contaminants of concern. So the top two boxes there are probably more for green building standard projects. The two bottom boxes there are probably more for your standard ASHRAE application. And we're constantly coming out with new products around these same filters that we've been producing commercially for almost 15 years now. So it's not a new technology. We've been doing this commercially for 15 years. But we can implement, for example, the 100Z, which is a small 4-filter system that can go into a drop ceiling really easily and reduce the amount of outside air on relatively small spaces as well. So any size application, and any goals that you have, we can help meet. Drilling down just on one of our units here, it's just that simple. We have a pre-filter here in front of our sorbent filter bank. You change that pre-filter on your regular MERV filter replacement cycle. But these sorbent filters are good for 2 years. And then we have our own internal fan so that this system can be easily retrofitted or deployed in new construction without increasing static across the systems. With that, I promised to wrap a few minutes early. It's been about 8 minutes since our last time check. So Karthik and I just wanted to thank you for your time today. If there's any questions, please drop them in the chat. Anything you want to hear more about, I'm happy to talk about it. We're also happy to do presentations for your individual firms with our partner, Odell, as well.
That's awesome, Ted. Really great presentation and super interesting, actually. I've listed a whole bunch of questions that I have, and I'll continue to watch and monitor the Q&A. There's one or two sitting there now too. So the first question I have is really around solutioning. So you talked a lot about form factors, and you talked about kind of how they would apply to the built environment. And one of the things that struck me a little bit about that conversation was, and in a positive way, is that by implementing a solution like this, to filter out some of those contaminants, you're able to achieve net reductions in some of your prime movers, right? Your chillers and perhaps some of your other fans and boilers and other things, and that it almost, or in many cases, completely offsets the additional cost of the new filtration. But I was wondering the context of retrofit. I mean, I know that we're going to continue to build new buildings. The Ottawa Public Library that you showed is a beautiful building, and it's going to be a great landmark here in Ottawa. And there will be many others like that, in our area and internationally. But there's also hundreds and hundreds and hundreds of buildings we have to retrofit. So can you just speak a little bit to the value proposition, and perhaps in the context of payback or ROI for retrofit scenarios?
Yeah, absolutely. So let's take a look at a specific scenario here for a retrofit. This was originally a retail space, a specific shoe company that was going out of business. And the space was getting moved into by a split co-working and daycare. Kind of a cool concept where you have both. Drop your kids off next door, you're across the hall, and you can take your meetings. And in this specific application, the occupancy profile changes drastically. So this is the same brick and mortar that we had before, but normally would require over $100,000 of HVAC improvements to get additional outside air deployed to that building. So what do we do here to reduce first costs? Well, in terms of reducing first costs, by deploying 2 of these filter boxes, these 200Ms here, we eliminated the need for 25 tons of new equipment. That equipment was going to go into a parking space. So we now saved a parking space as well. And eliminating that need for equipment saved that roughly $100,000 in first costs, even after our equipment costs. And so part of the retrofit applications that we typically see is, we'll see, for example, a university wanting to move their legislative school to a singular office floor in Washington, D.C. Well, each floor only has so much outside air to give from the building as a whole. how can we move more occupants into that space without adversely affecting indoor air quality and without having to upgrade the entire building to HVAC? And the answer is to run the IAQp calcs for that floor using the square footage and occupancy and the available outside air that we have, and we can all of a sudden flip that space by adding more filtration.
Right on. Sorry, did you have more on that?
I think just more specifically answering your question in terms of payback, in a lot of those types of scenarios, it's a net deduct versus what's initially proposed. So there is payback is either 0 or infinity. I haven't figured it out over time, but it's somewhere in that range.
Love it. I love the concept of infinity. I've tried to explain this to my children several times, and it's mesmerizing to them because they say infinity or infinity to the infinity, and I just love that concept of infinity. But no, that's great, and I like the application of repurposing. I think we're probably all going to see much more repurposing of buildings, particularly as we exit pandemic land, and we're finding out that perhaps we can be productive at home some of the time, right? Or some people probably don't need the offices, or they want different kinds of co-working. And this is a great hybrid where you say, come to the office and don't worry, we have childcare for you right next door. So it's a really good marriage of spaces. And interestingly, I actually worked for 7 years in that Market Square building early on in my career. So that was my home office was in that building in a repurposed mall. So small world.
Wild.
Yeah,
that's
small
cool.
world. That's cool. Okay, so another question that we had that's come up. It came up in the chat, and it was something I was thinking about as well. And you did mention, outdoor the difference between outdoor contaminants and indoor contaminants, and some of the procedural things, procedural considerations around the differences in contamination. And then I got to reflecting and thinking a little bit about, special outdoor emissions. Like, for instance, if you happen to live in an area where there's a propensity for forest fires. And I'm thinking about the West, United States and Canada. Last summer was a doozy, and I've heard that this summer it's going to start just as early or earlier and be just as bad. And so I'm thinking about that, and in the context too of the emissions that might come from automobiles and buses and such that are on the streets. So carbon monoxide and NOx. The filtration media that you have, it's effective to also remove those contaminants, we're presuming?
Yeah, so two benefits there. One is those outdoor generated contaminants, if you need to ventilate that building to the ventilation rate procedure level, you're bringing in more of those contaminants. Not great. So with the IAQp actually has a multiplying effect that helps us ensure better indoor air quality, which is one, we're introducing less of those contaminants into the space. And two is these filters do remove those types of contaminants. So NOx, SOx, BTX, those are all derivatives of this list here. So BTX is benzene, toluene, and xylene. NOx is similarly to that list as well. So yes, we absolutely remove those contaminants of concern. And by introducing less of those into the space, you end up with better IAQ. So yep, absolutely.
Yeah, right on. That's cool. So kind of a follow-on to that, as engineers and technologists, we've been taught and we've learned to design to the worst case. Of course, you have to design for the coldest, winter hour, and you have to design for the warmest summer hour, and all of these things. You want to design for the maximum number of occupants. So when you're thinking about in the context of these, particularly the outdoor contaminants, right? Things that we'd have no control over. I mean, you can control off-gassing to some degree, and you can control some of those other things with respect to products chosen and other means, but you can't really control the number of buses that drive by your building or the forest fire next door. Does higher concentrations of the limited number of outdoor emissions that are coming into the building degrade the life, that 2-year media life on the sorbent?
Yep, absolutely. So the nice thing about sorbent filters is, since they're removing gaseous contaminants, it's a little bit of a mind shift versus how we typically think about, for example, MERV filtration, where MERV filters are replaced based on loading most of the time. They load up with particulates, and then you need to replace them. With gases, we essentially have for everything except for CO2, we essentially have an infinite substrate for those contaminants to attach to that polymer. They're very, very small. They're very, very infrequent relatively in terms of the total volume of air. And so loading is not what drives the filter replacement cycle. Also, it's not building run hours. So basically, the sorbent media, that polymer on those high surface area granules, oxidizes at a very knowable rate. And so as soon as the filter is manufactured and it's taken out of its vacuum sealed bag and placed into operation, that's when the time clock starts. And so whether it's a 24/7 building or whether it's, 8x5, the filters still need to be replaced once every 2 years. Now, I mentioned that CO2 we don't have an infinite substrate for, and that's where these filters are able to undergo a process called regeneration. If for CO2 specifically, we are removing that contaminant and controlling that contaminant is necessary based on the occupancy profile and the amount of outside air we're still bringing in, then we can use devices that remove CO2. They're a little bit larger, a little bit more complex, and those filters can actually regenerate on a daily basis. That process is also very knowable. It's a low temperature swing regeneration. And that basically, we release the small amount of CO2 that we've captured, we release that outside the space, and then that substrate is freed up for CO2 again. But for all these other ASHRAE required contaminants of concern, we know that whether we go into an embalming facility with a ton of formaldehyde, or we go into a K through 12, which hopefully doesn't have a lot of formaldehyde, we're going to have enough substrate to grab that. And really what's driving the filter replacement is we're using our year 2 end of life filter efficiency based on that oxidation rate.
Oh, right on. That's cool. So that also, you directly, but unintentionally answered another question that had come up which was around, if you have a lower occupant load than planned, if it extends the life. So you've confirmed that is not the case, that these are, you're really talking about, the longevity that the polymer coating can work for, right? Because it is oxidizing constantly over time. Okay.
Exactly right. So our published, if you look at our third-party published lab data, you'll see that our single pass efficiency on, for example, formaldehyde is 99.5%. In the calculations, we use 72%. That gives us a pretty big buffer for the first 2 years versus our year 2 end of life. And that also is our, we're using a much lower efficiency based on, the oxidation of that polymer.
Cool. So, speaking about the media, the polymer infused media, do you have different media products? Like, are there different compound recipes that you would, choose for different, spaces or environments?
Yeah, our filters were built to be applicable to pretty much any ASHRAE 62.1 space. So we're pretty boring. We focus in on warehouses, offices, schools, churches, auditoriums, places like that. So we don't need to do custom blends for our filters. So we manufacture essentially one filter type. Now, how that filter operates can vary based on the form factor. So I mentioned like some of our devices remove CO2, some don't. The only difference between those two is whether or not the box that we're shipping has the ability to regenerate those filters or not. And if they're not regenerated, those filters are just not removing CO2. They're loaded with CO2, but able to remove all of these other contaminants of concern.
Yeah, well, it makes it simple. It makes it simple for us. You're not somebody wouldn't necessarily need to be worried about choosing the wrong media or specifying the wrong thing. And certainly from an operations perspective, not having 3 or 4 different kinds of filter media on the shelf and trying to figure out which one goes in the box. I would think that would be advantageous as well. That's interesting.
The selection process very easy and makes it so that I don't have to be that smart because we just have one filter and a couple of boxes, right?
Yeah, right on. Well, you can still be smart just about other things.
Sure.
That's awesome. Yeah, that's awesome. And I think the last question, I don't have any more questions in the Q&A box, but the last thing I wanted to ask, and it's again around the media. So in terms of accessing the media, I'm presuming that this is, I mean, you've licensed the chemical that goes into the media itself. Like, are you the exclusive provider of the media for these boxes if somebody buys one and puts it into their building, or are there other people that can supply that sorbent material?
So the IAQp as a methodology is not exclusive to Invarid. What you really want to hone in on when selecting a product is, I mentioned formaldehyde a few times. That's really the contaminant of concern that drives the calculations because of the high emission rates that ASHRAE has given us and the low design limits. So a combination of other products or specific products might be out there that can achieve the same efficiencies, but I would say that for the dollar and for the simplicity, we're typically the go-to product for these types of applications, just because this is what we're built to do.
Yeah, that's great. Listen, this has been a really interesting conversation, and I'm really happy. I hadn't been, outside of hearing about about the product kind of a little bit on the periphery. I hadn't had a chance to delve right down into it, and this presentation has really opened my eyes to an option out there to help reduce ventilation rates while still achieving indoor air quality thresholds and requirements. And I'm really happy that we've had this conversation, and I wanted to thank you again for taking the time and being patient with the questions. And much appreciated.
It's my pleasure. Thanks so much for everything that AEE does to encourage education in the space. I also want to give Karthik a big thanks for helping us prepare for this presentation and the slides. And thank you to Odell as well, who sponsored this and who continues to be able to help locally in the market deploy Invarid products and the IAQp more broadly. So thanks so much for the time, Andrew. Really a pleasure working with you and the whole team.
Yeah, fantastic. And you as well. Right, everyone, thanks for joining us for today, and have a great rest of the day from wherever you are, whichever time zone. Thanks a lot.